Okay, in this question we're going to look at solving HCF for 3 numbers instead of 2, but we are still going to be using method 1. So there's actually no difference in using in having 3 or 4 numbers and using method 1, because you're going to repeat all 3 steps for every single individual number. So let me show you the 2 steps first, and then we can go and discuss on the 3rd step. So the first 2 steps are just to prime factorize each number, and the second step is writing them into index notation. So let's quickly just do these 2 first. Alright, so what we've done right now is just the step 1, which is the prime factorization of each number. Now we're going to write them all in index notation. Alright, so what we have now is we have already completed step 1 and we've done step 2, index notation. So now we're going to step 3. So in this case, exactly what we did earlier, we need to compare and we need to pick the smallest index of the common base only. So all 3 must have the same common base. So if you look carefully, you realize all of them have a 2 and all of them have a 3. So we go back to rearranging them correctly for your step 3. So this is how you arrange them. Alright, so we arrange them neatly in such a way that all the common numbers or common bases are just aligned. So in this case, we'll go back to just boxing up all the different bases that are used in this question. Okay, so here is 5 and this is 7. Now, so like we said, we need to pick the smallest index of a common base only. So if you look at this, for the base 2, all 3 of numbers have it. Base 3, all 3 numbers have it. But because the other 2 don't have it, so we will not look at them because they don't have a common base. So now going back to the base 2, we pick the lowest base possible. So in this case, we have 2 to the power of 2 or 2 squared. And for 3, the lowest base would be 3 to the power, lowest index would be 1. So this would just be 3. So therefore, the answer for this question would be just 12.